Hello everyone, welcome to Physics online classes for class 12 students. Let us continue chapter 6 Electromagnetic Induction. Today we are going to derive an expression for alternating EMF or alternating current. So this is the last part of this chapter. Alternating EMF or alternating current, we can also call it as instantaneous EMF induced in a coil rotating in a uniform magnetic field. So let us derive an expression for instantaneous EMF or alternating EMF. Yes, to derive an expression for alternating EMF or alternating current, or we can also call it as instantaneous EMF induced in a coil when it is rotating in uniform magnetic field. Now let us observe this diagram. We can observe here. Let us consider a uniform magnetic field, this horizontal line with arrow mark that gives uniform magnetic field. In this uniform magnetic field, we consider angle theta. So this angle theta is between magnetic field lines, observe here, magnetic field lines and normal drawn to the given coil. So this is angle theta. What is angle theta here? Theta is angle between directions of magnetic field B and the area vector A. That means normal drawn to the given surface. So that gives the value of theta. Now here, when this coil is rotated in this uniform magnetic field, then the magnetic flux linked with this coil changes at any instant of time. Right? Now here we can consider the magnetic flux equation, that is pi equal to B dot A, or we can take it as BA cos theta. Right? So you can observe the terms. A is area of the coil. B is strength of uniform magnetic field. N is number of turns in the coil. Omega is uniform angular velocity of the coil. Theta equal to omega into T, that is angle made by the coil in the time T, and R is resistance of the coil. So these are the terms related to this expression. So we have to know all these terms. A is area, B is magnetic field, N is number of turns, omega is angular velocity, theta is angle between direction of magnetic field and normal drawn to the given surface. In place of theta, we can write omega into T, because we know that omega is rate of change of angular displacement, that is omega equal to theta divided by T. Therefore, theta equal to omega into T. This is angle made by the coil in time T, and capital R gives resistance of the coil. Now I am going to consider the magnetic flux linked with the coil at any instant of time T. Let us consider magnetic flux linked with the coil. Magnetic flux linked with the coil at any instant of time. At any instant of time T is given by, we know the magnetic flux equation, that is pi equal to B dot A, or we can take BA cos theta. We considered pi equal to BA cos theta. This is only for one turn. If that coil is having only one turn, then we can write this equation. Suppose if it contains n number of turns, then this equation can be written as pi equal to NBA cos theta. This is for n number of turns. For one turn we can write BA cos theta. For n number of turns we can write NBA cos theta. Right? So now I am going to rewrite this equation as NBA cos of, in place of theta, I am going to write omega t. Because we know that omega is angular velocity, rate of change of angular displacement is called angular velocity, omega equal to theta by t, or we can write theta equal to omega into t. So in place of theta, I wrote omega t. Let us take it as equation number 1. So we got pi equal to NBA cos omega t. Now I am going to use Faraday's second law. We know that Faraday's second law is given by Faraday's second law is E equal to d pi divided by dt. This gives only magnitude. But according to Lenz's law, Lenz's law gives E equal to minus d pi divided by dt, because the Lenz's law gives polarity of induced EMF. Now let us take it as equation number 2. Now I am going to substitute equation 1 in equation number 2. Substitute equation 1 in equation number 2. Let us substitute equation 1 here. E equal to minus d divided by dt, keep as it is. In place of pi, we can write n b a cos omega t. Let us differentiate this equation. E equal to minus, keep as it is. Number of turns of the coil is constant, take outside. We considered uniform magnetic field. It is also constant, take outside. Then A is the area of the given coil. It is also constant, take outside. Remaining is d by dt of cos omega t. Let us differentiate cos omega t. See here, minus n b a, keep as it is. Differentiating cos omega t. Here, cos omega t, that gives minus sin omega t into omega, because this is the variable. So we can write this equation, minus into minus will be plus. The remaining is n a b omega sin omega t. What is the equation? n a b omega sin omega t. But here, in place of n a b omega, I am going to write E equal to E naught sin omega t. What I wrote here? In place of n a b omega, I wrote E naught sin omega t. E equal to E naught sin omega t. Then what is E naught? Observe here, where E naught is peak value of EMF. What is E naught? Peak value of EMF. Peak value means maximum value of EMF is denoted by E naught. Therefore, E naught is equal to how much? N A B omega. What is the value of peak value of EMF? N A B omega, and the value of E is E equal to E naught sin omega t. So this is an expression for alternating EMF or alternating current or instantaneous EMF induced in a coil rotating in a uniform magnetic field. Now we can study the 5 stages of a coil rotating in uniform magnetic field. In the previous class, we studied construction and working of AC generator. Here, when the coil is rotating in uniform magnetic field, we know that for every half rotation of the coil, induced current direction changes. For every half rotation, 0 to 90 degree, if it is perpendicular, then 90 to 180 degree, it is parallel to the magnetic field. Then 180 to 270, again it is perpendicular. Then for 270 to 360, again it is parallel. So in this way, for every half rotation, direction of induced EMF go on changes. Now let us study those 5 stages of a coil rotating in uniform magnetic field. Observe this diagram. There are 5 stages here. First one, this is the second stage, third stage, fourth stage and fifth stage. In the first stage, you can observe the metal plate or this coil PQRS. This coil is PQRS. The plane surface is perpendicular to magnetic field. When we rotate this magnetic field, initially this coil is perpendicular to the magnetic field. In the second diagram, the plane surface PQRS, when we rotate, now it is parallel to the magnetic field. Then in the third condition, again it is perpendicular to the magnetic field. Then in the fourth condition, it is parallel. In the fifth condition, again it is perpendicular and so on. So in the first stage, how is the plane surface? The plane surface is perpendicular to the magnetic field. Now observe here, I am going to write the equation. The first equation I am going to take. When the plane surface is perpendicular to the magnetic field, then theta equal to 90 degree we already studied. So we can consider when theta equal to 0 degree. 0 degree means what? The plane surface is perpendicular to magnetic field. The plane surface is perpendicular to magnetic field. When it is perpendicular to magnetic field, theta equal to 0 degree. We know that instantaneous EMF is given by the equation E equal to E naught sine omega t. Now I am going to use this equation. Observe here. E equal to E naught sine omega t. This equation I am going to use. Or we can write it as E equal to E naught sine theta, because theta equal to omega into t. So in place of theta, we can write 0 degree. Sine 0 is 0. 0 into anything will be 0. So we got E equal to 0. Right? E equal to 0, what it indicates? Here, when the plane surface is perpendicular to the magnetic field, then there is no induced EMF. Initially, there is no induced EMF because it is at rest, it is not rotating. Initial value induced EMF is 0. Then, when this coil starts to rotate, for every half rotation, for the first half rotation, when it completes the first half rotation, theta equal to how much? 90 degree. When theta equal to 90 degree, it means the plane surface is parallel to the magnetic field. The plane surface parallel to the magnetic field. When it is parallel to the magnetic field, we can substitute the value E equal to E naught sine theta. Theta is 90 degree. Sine 90 is equal to 1. So we got the answer E naught. E equal to E naught, that indicates induced EMF is maximum for the first half rotation. Initially, induced EMF is 0. For the first half rotation, now induced EMF is equal to E naught. E naught is peak value of EMF or maximum value of EMF. Right. Then for the second half rotation, for the next half rotation, theta equal to 180 degree, because now it is 90 degree. Now we can take when theta equal to 180 degree. For the third diagram, third half rotation, the plane surface is perpendicular to the magnetic field. The plane surface perpendicular to magnetic field. When it is perpendicular to magnetic field, theta equal to 180 degree. Substitute the value E equal to E naught sine of 180. Sine of 180 is how much? 0. 0 into anything will be 0. So induced EMF is 0 when theta equal to 180 degree. Then The fourth rotation, again we are rotating the coil. Now it is parallel to the magnetic field. So theta equal to 270 degree. So the surface is parallel. This surface is parallel to the magnetic field. Again substitute the value in the given equation. Equal to E naught sine theta. Theta is 270 degree. 270 sine 270 is minus 1. So we got the answer minus E naught. So here this value indicates that induced current is maximum, but it is maximum in opposite direction. Right? Then the last point for the last rotation. When theta equal to 360 degree, it completes one rotation. So 360 degree means the surface is perpendicular to magnetic field. When surface is perpendicular to magnetic field, so E equal to E naught sine of 360 degree. Sine 360 is 0. So we got E equal to 0. Observe all the values. Initially for the first value, initial value before rotation, E equal to 0, initial value. Observe this graph here. Induced current is 0 degree for the first value, this point. This is 0 degree. Then for the second rotation, we got E equal to E naught. E naught means it reaches peak value, maximum value. Observe this diagram. Induced current go on increases for the first half rotation. It reaches maximum value. Here angle is how much? 90 degree. Then for the third half rotation, theta equal to 180 degree. For 180 degree, for the third half rotation, again induced EMF is 0. It means that induced EMF go on decreases, finally it will comes to 0. So here the angle is 180 degree. Then for the next half rotation, theta equal to 270 degree, we got the answer E equal to minus E naught. Minus E naught means the induced current is increasing, but it is in opposite direction. So we can take along this direction. Now it reaches maximum value. So the value is 270 degree. Then for the last rotation, theta equal to 360 degree, induced EMF is 0. That means this induced current go on decreases in the opposite direction for theta equal to 360 degree. This completes one rotation. Initially, the time period is 0. For one complete rotation, time interval is taken as a time period. Small t is equal to capital T. Time interval is equal to time period because it completes one rotation for 360 degree. Right? Half of the rotation means 180 degree. So, time period is exactly t half or t divided by 2. For 90 degree, time is t divided by 4. For 270 degree, time is 3t divided by 4. So that gives when the coil is rotating in the uniform magnetic field, current is induced. How the current is induced here? The current go on increases from 0 to maximum. For second half rotation, maximum to minimum. For third half rotation, 0 to maximum, but it is in opposite direction, and so on. In this way, alternating current is generated using generator, AC generator. Alternating current means the magnitude and direction of the current is changing periodically. Now it is of the form sine wave. Sinusoidally, the current is changing. These are the 5 stages of a coil when it is rotating in the uniform magnetic field. So this is all about alternating EMF. We derived an expression for alternating EMF, that is E equal to E naught sine omega t. E naught is peak value or maximum value of EMF, and its value is E naught equal to NAB omega. Yes, then what is the conclusion? From the graph, it is found that the induced EMF or induced current in the coil changes its magnitude and direction after equal intervals of time. Such an EMF is called sinusoidal wave. It means alternating EMF, and the current is called alternating current. So this is what we came to know from the graph. So whatever the current is produced, its magnitude and directions are changing for every half rotation. For equal intervals of time, its magnitude and direction changes. So that EMF we can call it as a sinusoidal EMF, and the current is called alternating current. That's why in the next chapter, chapter number 7, we are going to study about alternating currents. Right. Now, the last part is different types of generator. There are 3 different types of generator. Mainly we are using hydroelectric generator, thermal generator, nuclear power generator. First one is hydroelectric generator. Hydro means water. So here, these are the generators in which armature is rotated by using water falling from the height. See here, in the generator, we already studied construction and working. You can remember the construction of AC generator. We considered a coil wounded over a soft iron core, which is called armature. This armature is rotated between 2 strong magnets. But here, how to rotate that armature is very important. Coil is rotating, armature is rotating by using the water which is falling from the height on the coil. Because of water fall from the height, coil starts to rotate, armature starts to rotate. So that type of generator we can call it as hydroelectric generator. Then second one, thermal generator. Thermal, heat energy. So these are the generators in which armature is rotated by using steam. Just by using steam, we are going to rotate the armature. So these type of generators we can call it as thermal generator. Then last one, nuclear power generator. Again, these are the generators in which armature is rotated by using steam. How to produce this steam? This steam is produced by heating cooler with the help of nuclear fuel. With the help of this nuclear fuel, they are going to generate heat energy. Using that, the steam is produced. That steam, when it is applied on the coil or the armature starts to rotate. So we can call it as nuclear power generator. So these are the different types of generator. This completes chapter 6, Electromagnetic Induction. So in this chapter, we studied Faraday's experiments, Faraday's laws, Lenz's law, motional EMF, magnetic flux, energy consideration in motional EMF, relation between induced charge and changing magnetic flux, and also we studied eddy currents, self-induction, mutual induction and self-inductance of a solenoid, mutual inductance of a solenoid, energy stored in the coil, and AC generator, construction and working. Then also we derived the last part, instantaneous EMF induced in a coil rotating in a uniform magnetic field. So this completes theoretical part of the chapter electromagnetic induction. So in the next session, we can solve numerical problems based on the chapter electromagnetic induction.